Good morning, students. I have started the chemical bonding in the last class, and I stopped at the hybridization concepts. At this point, I stopped in the last class, and I have taken the example of beryllium chloride and explained the hybridization in this molecule. So this molecule involves sp hybridization, and after doing the hybridization, the type of hybridization, we can also get its bond angle. It's 180 degrees and it is linear. So, if we know the type of hybridization, you can easily predict. You can predict the bond angle as well as the geometry of the molecule or shape of the molecule. This is the important application of hybridization. By knowing the type of hybridization, you can predict the bond angles in the molecule, and you can also predict the geometry of the molecule. So, since beryllium chloride has involved sp hybridization, the bond angle in beryllium chloride is 180 degrees and its geometry or its shape is linear, which is written here. So, this is beryllium chloride. It is a linear molecule. It lies in a straight line. It is a linear molecule, and the bond angle is 180 degrees. 180 degrees. Okay. So this is a brief about the sp hybridization. Now we shall go for the next type of hybridization, sp2 hybridization. I will explain how do you get sp2 hybridization. That I shall explain today by taking BCl3 as examples. BCl3, boron trichloride. Boron trichloride. So this I have taken the example. Okay. Now the first step is you have to select the central atom. Select the central atom. This is the first step. In this case, it is boron atom. Boron atom. Next, write its second step. Write its electronic configuration. And this is called the ground state configuration. Ground state configuration. Third, if necessary, consider the electronic configuration. in excited state. So, when we consider the electronic configuration in excited state, means if it is necessary. If it is not necessary, this configuration is sufficient. The ground state electronic configuration is sufficient. Next, number 4. Mix the atomic orbitals. Mix the atomic orbitals in order to get hybrid orbitals. Last step is the electrons present in these hybrid orbitals. These hybrid orbitals combine with electrons donated by Cl atoms. So these are the steps you have to follow to explain what type of hybridization is involved in this molecule. Okay. First you have to select the central atom. In this case the central atom is boron. Okay. Then you have to write this electronic configuration, and that electronic configuration is nothing but the ground state configuration. To write the electronic configuration, you must know the atomic number of boron. Atomic number goes related to. If you know atomic number, then you can easily write electronic configuration. Okay? If necessary, consider the electronic configuration in excited state. ಅವಶ್ಯಕತೆ ಇದ್ದರೆ ಮಾತ್ರ ಇದನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ಅವಶ್ಯಕತೆ ಇಲ್ಲದೆ ಹೋದರೆ this is sufficient. The ground state configuration is sufficient. Next, after writing the electronic configurations, you mix the atomic orbitals in order to get hybrid orbitals. Here, let me also tell you that mix the outermost orbital. Let me write. Mix the outermost atomic orbitals in order to get hybrid orbitals. After getting the hybrid orbitals, these hybrid orbitals contains unpaired electrons. So you can write here the unpaired electrons present in these hybrid orbitals combined with the electrons donated by or given by Cl atoms. Okay. So now we shall explain the hybridization of BCl3 on the basis of these 5 steps. So first step is the central atom is boron. I told you already, and its atomic number is 5. Okay, so its electronic configuration 1s2, 2s2, 2p1. This is the electronic configuration in ground state. So you write here outermost orbitals I have to consider. This I don't consider. This is second shell. Therefore, these are called outermost orbitals. Okay. Now you can write this is 2s2, 2p1. 2s2, 2p1. This is the ground state configuration. You can easily see here we have only one unpaired electron. But I require 3 unpaired electrons. I want 3 unpaired electrons. Why means in BCl3 I have 3 Cl atoms. So if these 3 Cl atoms wants to combine with boron, this boron should contain 3 unpaired electrons. It should contain 3 unpaired electrons. Here how many unpaired electrons are there? Only 1 unpaired electron is there. This is the paired electron. It is paired. This is unpaired. Okay? Only 1 unpaired is here in the ground state. But I want 3 unpaired because 3 Cl atoms should combine with boron atom. Hence, we have to consider the excited state. Excited state configuration is necessary now. ನಮಗೆ ಬೇಕಾಗಿದೆ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್. ಸೊ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತದೆ, one of this electron from 2s is sent to 2p. Then the configuration is this is 2s, this is 2p, 1 2. Okay, this is 2. This is the electronic configuration in excited state. Now you can easily see here 3 unpaired electrons are there. 3 unpaired electrons are there. Okay, so these 3 unpaired electrons are sufficient to combine with 3 Cl atoms. 3 Cl atoms. But before combining with the electrons of Cl, these electrons of boron will undergo hybridization. These orbitals will undergo hybridization. So which orbitals are going undergo hybridization? 1 2s. This is the 2s orbital. 1 2s orbital I have. And how many 2p orbitals are undergoing hybridization? 2. 2 2p orbitals. 1 2s. This is the 2s and I have only 1. And how many 2p orbitals are undergoing hybridization? 2. This is 1. This is 1. 2 2p orbitals are undergoing hybridization, and therefore you will get the new orbitals called hybrid orbitals. Hybrid orbitals. Okay. Before hybridization, I am calling them as atomic orbitals. After hybridization, I am calling them as hybrid orbitals. And the name of this hybrid orbitals is S1. S1. Don't worry about this number. P number, whatever you want to do. Then P2. S1, P2. Simply you can call it as sp2. Okay? You will get sp2 hybrid orbitals. Just about the way this total 1 plus 2. Totally how many you have? 3. So I will get 3 hybrid orbitals, and the name of the hybrid orbitals is sp2. sp2, sp2, sp2. So we get 3 sp2 orbitals and 1 unhybrid orbital is as it is. This is unhybrid orbital. This is the hybrid orbital. Okay, and this hybrid orbital contains 1 electron. This also contains 1 electron. This also contains 1 electron. This unhybrid orbital does not contain any electron. Okay. Now the electrons donated by Cl atoms will come and join here. This is the electron given by first Cl atom. This is the electron given by second Cl atom. This is the electron given by third Cl atom. Okay. So this is the unpaired electron of boron. This is the unpaired electron of boron. This is the unpaired electron of boron, and this is the unpaired electron of first Cl atom. This is unpaired electron of second Cl atom, and this is the unpaired electron of third Cl atom. So like this, you will get BCl3 molecule. BCl3 molecule. And here the hybridization involved is sp2. The hybridization involved is sp2. Since the hybridization is sp2, the bond angle is 120 degree. And the shape of the molecule, the geometry of the molecule is triangular. Okay, so I shall write here. So this is the geometry of the molecule, and you can measure any angle. It is 120. This is 120. It's a triangular shape. Okay, so depending upon the type of hybridization, you can predict the bond angle as well as the geometry or shape of the molecules. Let me take one more examples. Let us take methane. Methane example I have taken. Again, you have to follow the same steps. The central atom is carbon here. The central atom is carbon and its atomic number is 6. Its atomic number is 6. Write down its electronic configuration. 1s2, 2s2, 2p. Okay, so this is 2s. 2s contains 2 electrons and 2p contains 2 electrons. 1, 1. This is 2p. This is the ground state configuration. Ground state configuration. Again, you can see here, I have only 2 unpaired electrons. I have only 2 unpaired electrons, but I want 4. I want 4 unpaired electrons. 4 unpaired electrons because 4 hydrogen atoms should combine with carbon. 4 hydrogen atoms should combine with carbon. Therefore, I want 4 unpaired electrons. But how many I have? I have only 2. Therefore, I should get 2 more. If you want to get 2 more, you should consider excited state. You should consider excited state configuration. Excited state. Excited state configuration. This is called ground state configuration. Ground state configuration. So, in excited state configuration, one of the electron from 2s is sent to 2p. This is 2s. One, two. So this electron, ಎರಡು electron ಇದೆಯಲ್ಲ 2s ನಲ್ಲಿ ಒಂದು electron ಇಲ್ಲೇ ಉಳಿಸಿಕೊಂಡು another electron is sent to 2p. Is sent to 2p. Okay, this is 2p. So this is the excited state, a configuration of carbon atom. Now they will undergo hybridization. They will undergo 1 2s and 3 2p. 1 2 3. 1 2s and 3 2p. This is 1 2 3. So totally 4 orbitals, 4 atomic orbitals undergo hybridization and you get 4 hybrid orbitals. 1 2 3 4. 4 hybrid orbitals you get, and the name of this hybrid orbital is sp3. sp3, sp3 and sp3. So how do you get sp3 means? Here 1 2s is combining with 3 2p. 1 2s is combining with 3 2p. Okay? So therefore it is s1 p3. p3. s1 p3 or simply considered as sp3. So this sp3 hybrid orbital contains 1 electron. This also contains 1 electron. This also contains 1 electron and 1 electron. Okay? Now, each hydrogen atom, each hydrogen atom gives 1 electron to carbon. Each hydrogen atom gives 1 electron to carbon and atom to form a CH4 molecule. So this is the electron of first H, second H, third H, fourth H. The dotted arrows represent the electrons donated by H atoms. Okay, so like this, the CH4 molecule is formed. The CH4 molecule is formed, and in this formation of CH4 molecule, the hybridization involved is sp3. Since the hybridization is sp3, the bond angle is 109.5 degree, and the geometry of the molecule is tetrahedral. So this is the molecule and the bond angle is almost 109.5. You take any bond angle is 109.5 and the shape of the molecule is tetrahedral. Okay, so this is a brief about the sp3 hybridization. So similarly, we have the other type of hybridations, sp3d, sp3d2, sp3d3, etc. So we have also this type of hybridations, sp, sp2, sp3 and sp3d, sp3d2, sp3d3. So these are the different type of hybridations, and depending on the hybridations, the molecules have different bond angles and the molecules will have different geometries or shapes. Okay, so that we have to list in the form of a table. In the form of a table. First, here name of the hybridation, name of the hybridation, then we write what is bond angle and what is the geometry. Then you can write examples. So like this, you can put a table here, and in this table you just mention all the types of hybridation, what are the bond angles, what is the geometry or shape of the molecules, and write some examples for each type of hybridation. So this is brief about the hybridation, and let me repeat that. The definition of hybridation is hybridation is defined as the mixing of atomic orbitals of nearly equal energy in order to get the new orbitals called hybrid orbitals. Hybridation is defined as the mixing of atomic orbitals of nearly equal energy in order to get the new orbitals called hybrid orbitals. Okay? So, how many hybrid orbitals you will get means it depends upon the how many atomic orbitals are mixing. If two atomic orbitals are mixing, if two AO are mixing, if two atomic orbitals are mixing, you get two hybrid orbitals. If three are mixing, you get three. If you four atomic orbitals are mixing, you get four hybrid orbitals. So depending upon the number of atomic orbitals mixing, you get the same number of hybrid orbitals. So this is a brief about the hybridization concepts. And I shall give some of the molecules for homework, that is PCl5 and SF6. So these two molecules you work out, and this is nothing but the homework, and please mention what is the hybridization what is the hybridization involved in this molecule, then what is its bond angle, and what is its geometry. You explain all these three with respect to PCl5 molecule and with respect to SF6 molecule. So this is for homework, and in the next class I shall go for some more topics. Okay, thank you.